definition of a trace mineral is that it's the smallest of particulates or molecules. And the reason for that is they're water soluble also. They also happen to be an electrical conductor, which I'm about to show you. But basically, this is a jar of salt. And if we look at this jar of salt and first measure the circumference of the jar, the total surface area, I should say, of the jar, compare it to the sum of the surface area of each grain of salt, that will be greater than the surface area of this jar. Okay, that's basically the definition of water solubility. Since we're all made of water, it stands to reason that if things are more water soluble, they are more assimilatable. So trace minerals are the smallest of minerals, which means that they have a greater surface area for the water to interact with, and therefore potentially a greater chance of absorbing into your body. The larger ones are chelated minerals, which you've heard of chelated minerals, which have like a claw attached to them, like an amino acid claw to help them assimilate more. And then you have the metal minerals, which are the bigger ones, which potentially might not even be something that you can actually metabolize.
So what those three things that you tested for, are they considered trace minerals, or are they considered?
Well, we tested for the total dissolved solid content.
The other three, the three that we don't want, I forget what they were. Were they magnesium?
Oh, cadmium, mercury, and lead.
Right.
Those are heavy metals.
Okay, so they're not trace.
No, those are on the periodic table of the elements. Those are heavy metals. Those are.
I didn't do too well in science.
Those are the things.
I'm the artist.
What happens if you use like one of those Brita things, you know, you see on TV? That
Sure, most filters, I mean, and this is a great topic because filtration is a license to steal, but it's also a license for some people who are honest to do a great job, as is everything in life. And the thing about filters is most of them just reduce the total dissolved solid content by a certain percentage. So let's say that there's, just to make an easy mathematical formula for you, let's say that there are 100 parts per million total dissolved solids in the water, of which 50 are minerals that potentially could be beneficial to you, and 50 are things that are potentially negative for you, like cadmium, mercury, lead, and a whole bunch of other things. If you reduce the total dissolved solid content from 100 to 50, the filtration does not differentiate between good and bad. So you still have the same percentage of good to bad, just in an overall lesser degree. So you're still consuming it. Otherwise, but you know, is it better than doing nothing? Absolutely.
And what about something like Poland Springs, or just
Well, let's not use
regular water?
brand names, but yeah.
Oh.
But well, let me just say this to you. The thing that bothers me about all mineral water is first, it might not be clean, but then once they clean it, if it is clean, it's going into plastic. And I have a little problem with that. This is a typical bottle that you find at like a sports shop that you would run with or bike with. And the first time we used this, we put our distilled water into this bottle. We were outside on a hot day, and when we took our first sip, our throats burned. Distilled water is completely clean. That couldn't possibly have been the cause of it. If you pass this around or come up later, this smells like plastic, like you can't believe. And the water will taste like it in very short order. And plastic can leach into water. Does all plastic leach into water? Supposedly not. Some plastics are less likely to do that. Also, heat has something to do with it also, because heat accelerates molecular movement, which makes things potentially, leach into the water a little more in terms of plastic. So anyway, to answer your question, there's a possibility that the plastic will contaminate the water, therefore not something we want to go near. The other thing is, it doesn't cost a lot to make water once you buy this thing, or what they use. I mean, you have to make a purchase, but ultimately, it's almost free. This, with electricity being calculated, maybe 25 to 30 cents a gallon, even here where electric's expensive. So at the end of 6 months, if you're buying bottled water, you probably bought one of these, but you don't have one. Right? So to make the purchase is probably a pretty good idea. And then store it in what we use, at the very least, which is a non-leachable container. So now I know that the water is 100% clean because I cleaned it. I know that it's continued to maintain its cleanliness or purity because we kept it in a container that doesn't leach, and it doesn't cost anything. How can you go wrong? It just doesn't make any sense to do it any other way. When it comes to showering, we started using a particular type of shower filter that deals with water on a different level because it's fast-moving water. This is a very slow process. It takes 3 hours to make a gallon with this thing, and with bigger ones you can do it a little bit quicker, but it's still slow at best. And so this won't do it for showering, but there are technologies, nanoparticulate technologies, that actually neutralize the heavy metals and remove a lot of the bad things that are put into water, like chlorine and fluoride and things that really are not good for you to have on your skin. They dry your skin out at the very least. And Charlene is a perfect example of it because her hair was something that was always, a problem for her. She used to use lots of conditioner, and comb it through, and I'd get into the shower after, and the bathtub was like a skating rink. And since we started using a filter, she doesn't need to use as much. She's using the same shampoos, so it wasn't the shampoo. So ultimately, the water was really hammering away at her hair and making it straw-like. And now I get in the shower after she shampoos and conditions, and it's not very slippery, so it was a pretty big positive. On another level, she's a big bath taker. And so this company makes a bath filter. And it takes a little longer to fill up because not all faucets in baths are the same size and shape, so you have to have this universal one that has a hole on top, which means there's an open and ended hole on one side that water can come out of if you run it too quickly. So it takes about twice as long to fill up a bathtub. And you know, one day she didn't want to take a bath. 2 hours later, she wanted to take a bath that minute. It only takes about 10 minutes to fill up the bathtub. But she got in and she got right out. She felt the difference after 2 weeks of taking a bath, having used the bubble, the bath bubble they call it, and then taking one without it. She knew right away there was a big difference. So, you know, we have a personal result that we can actually feel. So that's, you know, something to think about. All of these things are suggestions for you. I'm happy to, you know, steer you in directions, you know, to talk to people. But ultimately, these decisions are yours to make based upon your experiences and doing some research. I'm just going to help you cut to the chase a little bit more. And water is like a huge issue.